Hello everyone, let's go ahead and take a look at the inverse trig functions. Now before we can actually get into the inverse trig functions, we need to go ahead and take a look at our trig functions, which again, given an angle, will give us a particular ratio. So what I have drawn here is y is equal to sine, the domain being x is an element of the real numbers, and the range being absolute value of y is less than or equal to 1. I also have y is equal to cosine drawn, and I also have y is equal to tan x drawn. And again, we're going to go ahead and just limit ourselves from negative pi over 2 to pi, because that's the only part that we really need to consider when talking about the inverse trig functions. So what are the inverse trig functions? Well, the inverse trig functions, remember, are derived from the values of the trig function themselves, except for the inverse trig function undoes what the trig function did. So what happens then is that with the inverse trig functions, if you give me a particular ratio, the inverse trig function will produce a particular angle. Now before we go ahead and take a look at how we can generate these inverse trig functions, we need to go ahead and review very briefly what's necessary in order for us to be able to find an inverse function. So remember, we had relations, and relations are going to be any mathematical relationship that joins x and y, which is the independent and the dependent variable. Now in order for a particular relation to be considered a function, it needs to pass the vertical line test. And when we go ahead and take a look at y is equal to sine x, y is equal to cosine x, and y is equal to tan x, if we look at it from a graphical perspective, every one of those functions, trig functions, will indeed pass the vertical line test. Now, in order for us to have an inverse function, we need to make sure that the function also passes the horizontal line test so that we can consider the function a one-to-one function. Now, if we go ahead and take a look at our trig functions, of course, our trig functions are not one-to-one functions. And the reason for that is because trig functions are by nature periodic. So, how do we go about making a function which is not one-to-one to start off with? How do we make it one-to-one? Well, the way that we do that is we minimize or limit the domain. So in other words, we want to make the domain as small as possible, yet include all the range values that's there, and include the origin as part of the domain. So when we go ahead and take a look at, say for example, sine of x, if we wanted to go ahead and make this particular non-one-to-one function a one-to-one function, we need to go ahead and limit the domain. So in order to do that, we need to go ahead and be very precise about making sure to include all of the range values, and at the same time making the domain as small as possible for sine. So what we'll also do is include the origin. So if I go ahead and take a look at the origin here, if I go positive and I go up here and I go back down, all of a sudden, and once I go back down this way, the function is no longer going to be passing the horizontal line test, which again is something that we need in order for the function to be one-to-one. So what I'm going to do then is I'm going to say, well, let's limit it then. Let's go ahead and take this part off. And let's also go ahead and take this part off here. And if we do that to the sine function, then what happens now is by limiting the domain of the sine function, we now have on this particular domain here, all the range values of the sine function, all the possible range values of the sine function with a limited domain, and also that is now a one-to-one function. So what happens then is if we go ahead and reflect this about the line y is equal to x, which gives us graphically the graph of the inverse trig function, we'll come up with what is called y is equal to inverse sine x, or also known as the arcsine of x. So what happens then is that the domain is going to be x is less than or equal to 1, and the range in this case is going to be the negative pi over 2 less than or equal to y is less than or equal to pi over 2. Okay, let's go ahead and take a look at how we want to do that for cosine now. Now for cosine, of course, if we go ahead and start here, and if we go in a positive direction and we keep going down, then of course once we get down to here, we've again included the entire range values of our trig function. Now of course all of the rest of it, we do not need anymore in order to make sure that our cosine trig function is actually going to be a one-to-one function. Okay, so if we again reflect that particular portion of the y is equal to cosine graph about the line y is equal to x, we will be able to come up with what we have as y is equal to the inverse cosine of x, or the arc cosine of x. So this is the domain and this is the range. Okay, tangent of x, again, if we go ahead and take a look at tangent, we have to approach it from the same perspective. Notice that the periodic nature of the function does not allow it to be a one-to-one function, and so we need to go ahead and limit the domain so that it becomes one-to-one. Now tangent, of course, is very nice because of the fact that it has the asymptotes, which are then going to go ahead and tell us exactly one branch, which is what the main value should be for one branch to exist, so that we include all of the range values that are possible for the inverse tangent. So again, if we go ahead and just eliminate all of these other branches that follow, and all of these other branches that follow, and if we go ahead and reflect that particular branch about the line y is equal to x, we will be able to come up with y is equal to the inverse tangent of x, or the arc tan of x. Here's the domain and here's the range. So I invite you to go ahead and take a look at some of the other graphs that you have in your textbook that will show the reflection. I'm not going to try to draw the reflection here because it gets a little bit tricky now that my domain is going to be between 1 and negative 1. But I will go ahead and allow you to go ahead and take a look at that those textbook examples for more precise graphs. Now, once we go ahead and establish how to go about determining how to limit our domain for the trig functions so that they become a one-to-one function, so that we can then go ahead and find the inverse trig function, how do we apply some of this knowledge? Well, there's a couple of things that we need to be careful of. And say, for example, let's take a look at this. We know that the sine of 210 degrees is equal to negative 1/2. But if we were to go ahead and take the inverse sine of both sides, notice that we come up with 210 is not equal to the inverse sine of negative 1/2. Because if you actually put the inverse sine of negative 1/2 into your calculator, you will come out with a negative 30-degree solution for your angle. Okay, now why is that? And that is because, of course, we had to limit the domain and range values of the original sine function to be able to make the inverse trig function a one-to-one function. The sine function to make that sine function a one-to-one function. Okay, so the one thing, in order to go ahead and make sure that we do not make these types of mistakes, the moral of the story is we just need to know which quadrant or range your resultant angle should be in and make the necessary adjustments. Because if we go ahead and think about negative 30, of course the sine of 210 is also going to give you the exact same result as the sine of negative 30, but then we just need to make the adjustments to come up with the angle that we're looking for. Okay, so let's go ahead and wrap things up here. Again, remember we said inverse trig functions, in order for them to exist, we need to make sure that our original trig functions are one-to-one. That means that we need to go ahead and limit the domain of the original sine, cosine, or tangent function. Reflect that about the line y is equal to x, and you can come up with the particular domain and range values for your inverse trig functions. Make sure to also go ahead and keep in mind that when we go ahead and solve for particular angles using the inverse trig function, we need to be very particular and very careful that we know which quadrant or which range our angle lies in. Okay, so we'll take a look at some examples, and we'll go over some problems and questions that you have the next time that we meet in class. See you next time. Bye-bye.